Good evening. We are now looking at the production and operation management test. This is all right. A quiz, or you can just simply say a test. So we can get down to question one. Question one was actually on forecasting and forecasting techniques. So under this one, um it was on forecasting, and in particular, this forecasting was on regression analysis. It was forecasting, and in particular, I was simply saying it was on regression. All right, so now the manager of the computer wants to develop next year's quarterly forecast of sales revenue for its brand laptops. The sales are seasonal, and the company believes the following most recent 8 quarters of sales should be representative of the next year's sales. So the sales, they depend on a quarter. So here we can use the aspect of uh, data deseasonalization. Okay, so now they're saying, tell me the forecast of next year's quarterly sales revenue for this line of laptops. Okay, and then they are simply saying for your working seasonal indexes must be 4 decimal places. The trend equation must have 3 decimal places, and the forecast must have 2 decimal points to fit in this equation. So this equation was not actually given. So what was supposed to be done here is to deseasonalize the data, okay, for us to get the question one answers correct. All right. So this is using the aspect of data deseasonalization. So meaning that the way this question was done, we had the quarter one and quarter two. So quarter one at the fact year one, we had year one and year two. Okay. Then for each of these years, we had quarter one, quarter two, quarter three, quarter four, and the sales values were also given. Okay, so the first one was 9.2, 5.4, 4.3, 14.1, we had 10.3, 6.4, 5.4, and 16.0. So on this one, the question was like, you are given the year one and year two. So under this one, we had quarter one, quarter two, quarter three, and quarter four. So meaning here we had the figures, the 9.2, the 5.4, then 4.3, then 14.1, then 10.3, 6.4, then the 5.4, 16.0. Here we are supposed to do the totals. So we are supposed to have the totals here. And then the average when getting the equation. So that equation, they solved it using this way. So the average, okay, So there was aspect of getting the SI, which is the seasonal index. So seasonal index. So the totals for the first one, 9.2 plus 10.3 is 19.5. 5.4 plus 6.4, 11.8, 4.3 plus 5.4, 9.7, then 14.1 plus 16, which was 30, 30.1. So the average there is 19.5 divided by 2, which is 9.75. 11.8 divided by 2 is 5.9. 9.7 divided by 2, 4.85. 30.1 divided by 2, 15.05. So here, this is how we need to find this table before we disaggregate the data. Now, there is aspect of finding the seasonal index. So seasonal index is equal to quarter average. So quarter average, then overall average, overall average. Then our overall average is actually equal to overall total, then over total number of measures, total number of measures. So our overall average, okay, is equal to our overall total. From the table, we can get the overall total here, 19.5 plus 11.8 plus 9.7 plus 30.1. So it's 71 point what? 21.1. That's the overall total there. So overall total number of measures. So 71.1 over total number of measures, there were 8. So meaning we are getting the 8.8875. Now, from here, the examiner actually mentions that determine the focus of next cells. So here, we are supposed to do the data deseasonalization. So there's a note here where they're saying, note your workings, the seasonal index must have 4 decimal points. The trend equation must have 3 decimal points, and the focus must have 2 decimal points. So this was the rule of the game. The rule, as we are looking at this question, which was focusing on data deseasonalization. So please take note of what is going on here. Okay, the cells, this is the Y, and then the quarter is X. Cells depend on the year. So this is what happens as we are using the regression line. All right, so this is not an issue because already we did forecasting using regression in QM, quantitative method. So now what happens here is that we now need to deseasonalize the data. So we have, this is our overall average. So meaning our seasonal index is equal to quarter average over overall average. This is how we find the seasonal index. And they have told us that for the seasonal index, we need to go for 4 decimal points, okay, for the seasonal index. So what is going on here is that we are going to find our seasonal index, which is quarter average over overall average. Our overall average is that amount 8.88. So this one divide by 8.8875. Okay, so meaning 9.75 divided by 8.8875, we are getting 1.1. They are telling us that the seasonal index should give us, seasonal index must be 4 decimal points. So we are going to have 1.0, 1.0970, 5.9 divided by 8.8875, 0.66. So 0.66, all right, 39. Then the other one, 4.85 divided by 8.8875, 0. What? 0.5457. Then 15.05 divided by 8.8875, 1.69, 1.6934. So now this one, we are supposed to now deseasonalize the data. Okay, we now deseasonalize the data.
Excuse me, sir.
No problem. Yes.
I think I missed it where you are dividing by 8 the totals, which is 71.1. You are dividing by 8. I'm wondering where the 8 is coming from.
Okay, no problem.
If,
Thanks very much.
if,
I will explain just now. Let me take you back.
okay.
Yes, let me take you back shortly. So I'm taking you back just in a bit. Okay, so that you'll be able to understand whatever is going on here. So this is year 1 and year 2. Okay, so let's go back a bit. So seasonal index formula is called SI. Seasonal index is equal to overall average, the quarter average over overall average. SI is equal to that. Now, overall average, we are finding the average for all these numbers. Okay, we are finding the average for this one, this one, this one, this one, this one, this one, this one. So as we add all those ones, we can add how many numbers we have there? 8. So let's find 9.2 plus 5.4 plus 4.3 plus 14.1 plus 10.3 plus 6.4 plus 5.4 plus 16. It's giving us 21.1. Are we together there?
Yes, we're together.
So we are, after adding all those, we find the average for year 1 and 2, these figures that I've ticked here, from 9.2 up to 16. So it's 21.1. Now, this one is the mean of these, it's the average of these numbers. So the average of those numbers It is this 8 here that you are getting now. So the average is 8. This is why this one is coming from.
Oh, okay.
Is that okay?
Yes, it's okay.
You're able to see the screen?
Yes, I'm able.
Okay, so now to deseasonalize the data, we divide the seasonal data by seasonal index. So deseasonalize, okay, so deseasonalize, so deseasonalized, we are going to divide seasonal values, you divide it by seasonal index. So seasonal values divided by seasonal index. So what I mean is the first one was 9.2. So 9.2 divided by the seasonal index, which is the 0. Okay, so the seasonal index for this column, okay, it's 1.0970. All right, 1.0970. That is for this first quarter. 1.09, 1 point, so this is it, 9 point, so 9.2 divided by, what are we having here? We are having the 1.097, 1.097, 1.097. Okay, then the other one here, so we can find out what figure we are going to get. Then again, the 10.3, then we divide this one by what? The same, 1.0970. Okay, we can find the value here. Then here we go for 5 point what? 5.4 divided by, and then here is 6.4 divided by. All right, so we divide by the seasonal index for this one, which was 0.6630, 0.6630, 0.6630. Even here, 0.6630. So we can get the answer here. Then the other one is 4.3. So 4.3 divided by, and then here we have 5.4. Okay, so 5.4 divided by. Then the other one should be 14.1 divided by, then 16 divided by. So let's check the seasonal indexes. Seasonal indexes that we have 0.5457, 0.5457, 0.5457. Even here, 0.5457. Then the other one here, the seasonal index is 1.6934. 1.6934. 1.6934. Then here also 1.6934. So we can actually get the values. So 10.3 divided by 1.097 is giving us 9.39. So 9.39 here. Then 9.2 divided by 1.097 8.39 to 8.39. So these are called deseasonalized cells. 5.4 divided by 0.6630, 8.14. So 8.14. 4.3 divided by 0.5457, 7.88. 7.88. Then the other one is 14.1 divided by 1.6934. Are people following so far? 8 point. You are following?
I'm following, sir.
6.4 divided by 0.66. So we are dividing by, so we are deseasonalizing the data. Simply, we are dividing the original data from the question here. From this question, these are called seasonalized data for year one, so this is year one and 4 quarters. That's why it was like that. And then year two at least, that's why it was initially presented this way. Okay, presented this way. For year one, 4 quarters, year two, 4 quarters, the totals, the average, the seasonal indexes. Then getting down to the here, we are simply saying that as we divide, let's say 9.65. So here this is 9.65. So 5.4 divided by 0.5457, 9.89. Then 16 divided by 1.6934, 9.45. 9.45. So when getting down to the other thing that we need to do, we need to actually sort out this one. Now using the regression analysis, we use these deseasonalized values, okay, to find the regression. So meaning that as we go, we are going to say X is representing like year one, so it's quarter one. Okay, so we got year one, that's quarter 1, 2, 3, 4. So year two will begin on this note. So year two will be on 5, 6, 7, and 8. And then the Y are the deseasonalized cells, which means this one is 8.39. These figures are coming from the Y we are coming from, 8.39, which is this one. Then going that way for year one, so 8.39. Getting down, we have 8.14, 8.14. We have 7.88, 7.88. Excuse me. We have 8.33, 8.33. Then 9.39. We have 9.65. Then 9.89. 9.45. So please, these figures are coming from the cells that are deseasonalized. And you remember in quantitative method, we had these kind of parameters where we need to find the total. So this is not an issue. We can enter the data in the calculator to find the regression equation, which is the deseasonalized one. So these values are coming from the table for data deseasonalization. All right, so meaning as we enter using the calculator, or as we can solve manually, so it is 1 comma 8.39 m plus 2 comma 8.14 m plus 3 comma 7.88 m plus 4 comma 8.33 m plus 5 comma 9.39 m plus 6 comma 9.65 m plus 7 comma 9.89 m plus 8 comma 9.45 m plus. So meaning the total of the x, okay, is 36. So x here is 36, and then the one for y is 71.12, 71.12. The x square is 204. Then you can get the y square is 636. 636, all right, 0.5442. Of course, they can get the other one, 331, okay, 0.31. So from here now, we can get down to the regression equation. Of course, you can find manually beta, okay, which is equal to summation of xy, okay, then minus summation of x multiplied by summation of y over n over the summation of x square minus summation of x square over n. And when getting our alpha is equal to y bar minus b x bar. So the regression equation here for this one, okay? So regression equation, we are going to have our y is equal to alpha then plus bx. So meaning that from here, you can say our y is equal to our alpha, you can even get it from the calculator way, okay? Okay, so we are getting down to, okay, the value there. And then our beta, okay, so we have the equation for the regression, okay? So here, just a minor aspect, because they are simply saying we need to calculate now the value of the regression equation using the data that has been deseasonalized. Okay. And then they are simply talking about, so here it's just a matter of rounding offs, because they're saying that seasonal indices must have 2 full decimal places. So meaning that it is just a matter of, as we come here, seasonal index must have 4 decimal places. So after doing the data personalization, we are getting these values. So meaning that according to the number of decimals that you are getting, we have to follow the equation here, because it was saying that according to the rules of the seasonal points, the decimal points will actually matter a lot. Okay, so so here 3 decimal points, the trend equation is 3. Focus must have 2 decimal points. Okay, so meaning these are the forecasts. they should have the 2 decimal points. And then the other one for seasonal of like 4 decimal places. So meaning here is just a matter of the seasonal points. So meaning as we look at this one, we can get even these ones. We are using the 2 decimal points, so we can use 4 decimal point for each of these data deseasonalization. So meaning these values here from the question, they're saying that we should go for 4 decimal points, because if we go for the 2 in this case, because there's a breakdown here that we should follow, the seasonal index must have 4, trend equation should have 3, which is this equation is a trend equation, and the focus must have 2, which are these focus for the CDA. So meaning that the deseasonalized cells must have also 4, because the seasonal points are using 4. So meaning here we can also revise these to 4. So meaning the 9.9.2, okay, then divide by 1.097 should give us 0.3865, 0.38. So we can, here we should use not this one, we can use the 0.3865. So this one should give us the 0, that is 8.3865. Then this one also, we should go for 5.4 divided by 0.6630, which is 0.814, 0.81448. Then this other one, 4.3 divided by 0.5457, so 7 point, this one will give us 7.87, 7.8798. We go for 4 decimal places. Then the other one is 14.1 divided by 1.6934, 8.32. So this one, okay, we just go for 4 decimal place. So here this one will give us 8.32, 8.32, that is 8.32, 8.3264. Then the other one, 10.3 divided by 1.097, 9.38, 9.3892, 9.3892. The 6.4 divided by 0.6630 is 9.6531. Okay, then the other one, 5.4 divided by 0.5457, 9.8955. Then the other one is 16 divided by 1.6934, 9.44. So this is 9.4484. So we can go for, these are the figures we need to use now. So from there, we can start solving for the equation. Then we go for the value that we are going to forecast. So then go for that one, 0.6531, 9.8955, 9.4484. So as we get to this one, it means that our x value, we should go 1, 2, 3, 4, 5, 6, 7, 8. Then our y we go for 4 decimal places, 8.3865, then 8.1448, then 7.8798, then 8.3264, 9.38 9.3892. Then the other one is 9.6531. Then 9.8955. Then 9.4484. So we can enter the data in a calculator, then find the equation, okay, using the combination of x and y. So 1 comma 8.3865 m plus 2 comma 8.1448 m plus 3 comma 7.8798 m plus 4 comma 8.3264 m plus 5 comma 9.3892 m plus 6 comma 9.6531 m plus 7 comma 9.8. Now, okay, so 7 comma 9.8955 m plus 8 comma 9.4484 m plus. So we can find our regression line, which is equal to alpha plus bx. So what is important is for you to understand the concept. Okay, so here is giving us our line to give us the 7.68. Okay, then plus the beta is giving us the 0.2 6 0.27 0.27. This is on using the data that has been deseasonalized. Okay, so this is on how this one was going about. So for this one, these answers they were just using from here, they were just using the direct way without it, but here the requirement was that they were supposed to use the seasonal index. So here, this equation, I suspect it was just done without using the seasonal index, that they found it using the normal regression x and y. So they found it this way, which wasn't supposed to be the case. All right, so we're supposed to use the seasonal indexes for the 4 decimal places, because they are even mentioning about the 4 decimal places here as we deseasonalize the data. So this one, whatever it came from, this one, this answer here, there's a bit of a question mark there. Okay, so this is how this question was supposed to be done. All right. So we need to move on to the other question. All right, so we can go to the other question now, which is on inventory management. Yes, so this question, when solving it normally, it was giving us approximately the 6.2 something. So, but they didn't deseasonalize it. which was not correct. All right. So it was supposed to be the correct answer is the one I've given out there, because it was on that one was supposed to be deseasonalized. Okay, it was supposed to be deseasonalized. All right, so we can look at this question to do with okay, we can look at question number 2, which one is on inventory. So this question is on inventory management for a publishing company. Okay, so this company has a demand and a constant way, which is 7,500. So demand is 7,500. The cost of one book is 27.5. The holding cost is 18%. And the production setup. So this is inventory management model 2, because they're talking about production. The equipment on which the book is produced has annual production of 21,000. So we have the aspect there. Annual demand is actually 7.5. Then annual production is 21,000. All right. Then the lead time is only so here we have from this one under inventory for this question, we have our demand is 7.5. Then we have our daily production, annual production is 21,000 copies. Then this is annual demand. Then from here, we have the other information to acquisition cost per unit price, okay, which is the acquisition cost is $27.5. Then the other thing that we have here is the working days of the year, the days of the year. We have 250. Okay, and then what happens here is that they actually want us to find out the setup cost we have there. Setup cost is 550. So setup cost, which is our S, is $550. So this question even came from the pamphlet there. Then the carrying cost they're saying is 18% of unit price. So meaning that our holding cost is 0.18 multiplied by 27.5. So our C is equal to 0.18 times 27.5 is 4.95, $4.95. So from here we can substitute our daily demand is equal to annual demand over days. So our daily demand is equal to annual, which is 7.5, then divide by the days of the year, which is 250. Our daily production is equal to annual production. So annual production over the days of the year. Okay, over days. So meaning that our annual production is 21,000 over 250. So we can find the answers here. 7.5 divided by 250 is 30. And then 21,000 divided by 250 is 84. So we can find our economic load size, which is equal to 2ds over C multiplied by P over P minus D. Okay, P minus what? D. So after this is done, we can find our economic load size to be 2 multiplied by 75, then multiplied by 550, which is the setup. On our C is 4.95. Okay, so all right, so all right, so okay. All right, so yes, so we can now say, and then multiply by our P. Our P is 84 over 84 minus 30. So our economic load size here, we can find the value. So the value for our economic load size will be, so we multiply those ones. So we can multiply 2 by 7,500 by 550 divided by 4.95. Okay, so 4.95, getting from here 4.95. Okay, so 2 by 75 by 550 divided by 4.95, then multiply by 84 divided by 54, then the square root of that answer is giving us our economic load size is actually equal to 1610.153. So this we can confirm here. So 13, so it's without, so it's the same whole number, the whole number. So it's just one what? 16. So our E, we're doing the whole number there. So you see, one economic load size is equal to 1610. Okay, then from here, we can now get down to the other one. So the other one says number of production runs per year, which is 4.66. Number of production runs is equal to, the number of production runs is equal to annual production over EO, the economic load size. So this is number 2. So our annual demand is 7,500. Then you divide this one by 1610. So 75 divided by 1610 is 4.66. So 4.66 here. So these, once the first one is correct, the Q is correct, meaning that every other thing is here down will also be correct. So the cycle time, which is number C, okay, so cycle time is just the formula for cycle time. So this was A. B, Then C, we had the cycle time. So cycle time is equal to Q over D multiplied by the days of the year. So meaning our Q, okay? So our Q is the 1610 over 75 then multiplied by 250 days. So 1610 divided by 75 times 250 is 53.67. 53.67. So this is according to, so this is what we have. So this one, this one, this one. Length of production run. Okay, so length of production run. We are even just saying our length of production run is actually going to be, okay, so length of production is actually going to be Q over P. Okay. So this is what we have here, which is 1610 over P is our 84. So meaning 1610 divided by 84 is 19.17, 19.17 days. Okay, so the examiner was giving a restriction in terms of the decimals. So 19.17 days, so this one's gone. Okay, so here now, maximum inventory level. The other one says maximum inventory for E.
Excuse me,
Yes, please.
what's the difference between production runs and cycle time?
Okay. The production now cycle time, which one? Are you talking about D? Are you talking about this D and the, or are you talking about the number of production runs?
I think you can start from the production runs and cycle time.
Oh, okay, so but have you understood the first one, economic lot size?
Yes, I have. I'm
Okay, so
following
this
how you
one,
get the
okay, so this
daily
is,
demand, the annual production.
okay. All right, so
Yeah.
now getting down to the number of production runs. How many times are you going to produce to meet the batch? So how many times are you going to produce this one to meet the annual demand? So this is number of production runs. Okay. How
Okay.
many times are you going to produce to meet the demand? Demand. So if you are going to produce at how many times? You're going to produce 4.66 times a year of this batch, 1,610 units to meet the demand of 7,500. That's what it means. So this is
Okay.
number. So number two is number of production runs. Now
Mm-hmm.
here, this is in days. Cycle time is the time taken between production runs. Time taken between production runs. So time taken between production runs. That is it. Only the cycle time. So time taken between production runs. So we have this one. All right. So I have to emphasize on this same one that you have asked me, the number of production runs. How many times we're going to produce to meet the annual demand? I will come back to it. Then after this, we can now get down to the other one. The other one that we are getting down to is the length of production run, time taken to produce a batch. So this one is time taken, okay, to produce a batch. To produce a batch. Which batch? To produce the 1,610. So because our Q is economic production size, which is economic load size, which is a 1,610. So on daily basis, we are producing 84 units. You can see the breakdown from here. This is our daily production. This is our daily demand. So daily demand is 30 units. Daily production is 84 units. So now the time taken to produce a batch is 19.17 days. All right. I don't know if I answered your question.
Yes, you have.
Now we go for maximum inventory level. So maximum inventory level, the formula. Now this one due to safety stock. Safety stock is a buffer stock that you keep for security reasons to cushion on demand units. So a formula is equal to P minus D, okay, then multiply by Q over P. So this is it on me. So the P minus D is simply called inventory build-up. So this is called inventory build-up. So when you're building up on inventory, it means that your daily production should be more than your daily demand so that you can have some stock that you can keep. So this is maximum inventory level without safety stock. Forget about these other pages. Okay, you can go to this one. So maximum inventory due to safety. So due to safety stock, we are answering that other question in that same page. Is equal to P minus D, then multiply by Q over P, then plus SS. SS simply means safety stock. So we can see that our P is 84. So our P there is 84 minus our small d is 30. Then multiply by our Q is 1610 over our P is 84. Then plus, let's find the safety stock. Safety stock, okay, our safety stock is equal to Z value, okay, then multiply by the standard deviation of demand. So Z value multiplied by standard deviation of demand. That is when you have the probability of stock out. When you have what? Probability of stock out from the runs. When you have the probability, okay, of stock out. Stock out probability. We use this formula for safety stock. Now, let's go back to the question, because these questions are detailed, please. Okay, they are detailed and they are part of the exam because they are detailed. There was a lot of information here for this question too. It was just not a question to do in a second. So it was a question that you require time. So now here we are telling us that the company uses 250 working days per year and lead time for production is 12 days. So there's aspect of lead time now there. So our LT, the lead time in this question was given. So our lead time was actually 12 days, and lead time is simply the time taken between when you place an order and when you receive that order. All right. Then the standard deviation of demand was 75. We can check it out from the question here. Standard deviation of demand was 75 copies. So meaning that all this information, we have answered this question up to T. So we are getting down now to E through to what? To G. All right. So we are on E to get the maximum using the Z value. So here they are saying that assume the company is willing to tolerate one stock out per year. So so if the company is willing to tolerate one stock out per year, it means that from the number of production runs, the probability that they will not produce will be, so probability, let's find the probability of stock out first. So probability, okay, of stock out is equal to 1 over number of production runs. So 1 over number of production runs. So meaning it is 1 out of, in this case, number of production runs was 4.66. We can go back, number of production runs, we had 4.66. So it's 1 over number of production runs, which is 4.66. Let's find probability of stock out. So meaning that probability of stock out would be 1 divided by 4.66, which is 0.24. So our probability is 0.2146. So this is the probability of stock out. So you check for this value in the Z table. So the Z tables will be given, the normal tables, you check for this probability. Now, in the case where you're using the cumulative probability, you simply say our probability should be, if we're using the cumulative tables that they usually give, so cumulative, so for cumulative tables, for Z tables, so cumulative tables, you simply locate, you say 1 minus the probability of stock out, 0.2146, okay, meaning that the service level of this company will be 1 minus 0.2146. So the service level of this company is 0.7854 because this probability of 0.24 is a probability of stock out. So what is the service level that they can satisfy customers in this company? So since the 0.2146, the probability of stock out, that they may not have the stock, they may not produce, in short, okay? So the probability that they'll produce is 1 minus that, which is the probability that they'll be able to produce 0.78. So you look for this value in the table. Look for this, okay? For this value in what? In Z table, okay? So you find that the value of Z here is 0.79. So use the cumulative tables, you will discover that the value of this is 0.79. So meaning our safety stock is equal to, the formula is equal to Z value multiplied by the standard deviation of demand. So meaning it will be 0.79 multiplied by 75, which was given. So meaning the 0.79 by 75 is 59.25. 59.25. This is our safety stock. So if we are going to allow the probability of stock out, okay, because they mentioned here that okay, assume the company is willing to tolerate one stock out per year, meaning the 1 out of the production runs they may not produce. So the probability of stock out we found, which is 0.2146. So the probability that they'll continue producing is 0.7854. So the safety stock is equal to Z value, which is we get from the service level that they'll still operate, which is 0.79 by 75, which is 59.25. So meaning when getting the maximum inventory, we are going to put the safety stock of 59.25. So our maximum inventory is actually going to be, we can break down this. So each one will be 54 by 1610 divided by 84, then plus the 59.25. So the answer is giving me 1094, okay, 0.25. But if you are to round off to the whole number here, it will just be maximum inventory due to self to be 1094. This is the answer that we are supposed to get. So as we go back and confirm something, so maximum inventory is 1094. So this is how the 1094 came in. All right. Then let's get into the part F of this question 2, because this was a detailed question. All right. So the reorder point. So reorder point, at what point are you going to order units of your commodity again? So on the reorder point, so the order point is equal to expected demand during our lead time, then plus the safety stock. So safety stock we have already found as 59.25. Then expected demand during lead time is equal to daily demand multiplied by the lead time. So this is the formula for expected demand during lead time. So it's daily demand multiplied by what? Lead time. So expected demand during lead time is equal to daily demand, which is 30, multiplied by lead time in the question was given. Our lead time in this question was 12 days. So meaning that we multiply, so what demand are we expecting during lead time? So 12 days, so meaning our multiply the 30 by 12, giving us the 360, okay? Then meaning that our order point will actually equal to expected demand is 360, then plus the 59.25. Okay, so our order point is actually going to be 360 plus 59.25 is giving us 419 0.24. So if you are saying we use the whole number here, it will be, the order point will only be 419. So this is now, so we can confirm something here. As we go, we can check so it's 419, the order point. So this question was a detailed question. It wasn't a straightforward question. So it's one of the toughest questions in inventory management. And lucky enough, we are going through it. And usually when this question comes in exam, you find that it's the entire 25 marks for you. So you need to understand what is going on. So we're looking at the last part of question 2, which is diverse. So we can go to the total stocking cost. All right. We're finding the total stocking cost. So on our total stocking cost, we are going to say also due to safety stock, due to safety stock, we are actually going to say it is Q over 2, then P minus D over P, then by C plus the D over Q on S, then plus safety stock multiplied by holding cost. Okay, holding cost. So here we know that our total stocking cost, our Q is 1610 over 2. Then P is 84 minus 30 over P is 84. On our carrying cost was 4.95 from the way where we started from here. Our carrying cost was 4.95. So we can actually substitute there and get whatever we need. So then plus the demand is 7,500 over Q is 1610. Our S is 550. This is our setup cost, which is our S. Then our safety stock was 59.25 by the holding cost, which is 4.95. So breaking down this, we can find the total stocking cost, which will give us, after breaking down 1610 divided by 2, multiplied by 54, divided by 84, multiplied by 4.95. It's giving us 26. Okay, so 262, that is for the first one, it's giving us 2561.625. Then plus the other one is 75 divided by 1610 multiplied by 550. So it's giving us, okay, 2562.11 plus the last one there is 59.25 multiplied by 5.495, which is 293. So 293.29. So adding all these ones, we are getting a total stocking cost as 2561.625 plus 2562.11 plus 293.29. So getting 5417.025. So this is our total stocking cost. Okay, cost of this is a holding cost. So we have this is holding, okay, holding cost, and then this other one is setup cost. The other one is setup cost. All right. So this is a setup cost. So this is how this one was done. All right. So 54.0. So this is how they got this one as well. Okay. Getting down to this this quiz. All right. So meaning the other questions as we go, we need to break them down so that you understand thoroughly. Well, now these other questions needs to be done. So question 5, an example. To get a variable to promise, you simply say it is equal to MPS, then minus the, so it's as MPS minus customer orders, minus customer orders. So this one, it was not an issue. So meaning the answer here, they subtracted 100 minus 65, they got 35. And then here is 100 minus 46, which should give us a 54. So the answer is 54 here. Then here they found 100 minus 30. They got the answers here. So this is how they got the values. Okay, so here there was a variable to promise because there was a skill state to sort out that one. All right, so meaning there is an aspect of 2. Okay, so this is how question 5 was done as well. So these other ones, we really need to come and just go through the rest of these other questions. All right. I'm sure you have picked up 1 or 2 things. Excuse me?
Yes, we have, sir. I have.
Yeah, so what is important, especially question 2, I really want you to go through question 2. Question 2
Okay.
is dynamic. I think you've seen how diverse question 2 is. It is also
Yeah.
it's also in the pamphlet. So I'm even encouraging you to buy the pamphlet when you do a number of questions that are there, because these questions are recycled. So you can talk to Mr. Njovu, you can get the pamphlet if you haven't gotten one yet. So you can
Okay.
you can end the class for now.
Okay. Thank you. Thank you.